Hello, grade 7 learners! In this reviewer, we will strengthen our understanding of square roots, cube roots, and irrational numbers. We will also learn how to locate irrational numbers on a number line. Let's work through examples together and practice until these skills become easier. A square root asks us, what number multiplied by itself gives this number? Since 5 times 5 is 25, the principal square root of 25 is 5. Remember that the radical symbol represents the positive or principal square root. These are some of the perfect squares you should memorize. Knowing them will help you determine square roots quickly. For example, because 9 squared is 81, we immediately know that the square root of 81 is 9. Find square root of 144. Solution. Ask, what number multiplied by itself equals 144? 12 times 12 equals 144. Therefore, square root of 144 equals 12. Square root of 169. Since 13 times 13 equals 169, therefore, square root of 169 equals 13. Pause the video and try the 3 questions first. For number 1, think of the number that produces 64 when squared. For number 2, 15 squared gives 225. And for number 3, 20 squared gives 400. A cube root is different from a square root because we multiply the number 3 times. Since 3 times 3 times 3 equals 27, the cube root of 27 is 3. Memorizing common perfect cubes will make cube root problems much faster. Start with the cubes from 1 to 10. For example, 7 cubed is 343, so the cube root of 343 is 7. To find a cube root, determine the number that is multiplied by itself 3 times. 6 cubed is 216, while 9 cubed is 729. Try each one before checking the answer. Remember, cube roots involve multiplying the same number 3 times. Rational numbers can be written as a fraction of integers. Irrational numbers cannot. Their decimals continue forever without repeating a fixed pattern. Many irrational numbers appear when we take the square root or cube root of numbers that are not perfect powers. Here is an important shortcut. For a whole number inside a square root, check whether it is a perfect square. If it is, the square root is rational. If it is not a perfect square, its square root is irrational. For cube roots, check whether the number is a perfect cube. The cube root of 27 is 3, which is rational. But the cube root of 2 is irrational, because 2 is not a perfect cube. To locate the square root of 2, first find the two consecutive whole numbers whose squares surround 2. 1 squared is 1, and 2 squared is 4. So the square root of 2 is between 1 and 2. Its approximate value is 1.414. 7 is between 4 and 9, which are the squares of 2 and 3. Therefore, the square root of 7 must be between 2 and 3. Since its approximate value is 2.646, it is closer to 3. Because 10 lies between 8 and 27, and those are 2 cubed and 3 cubed, the cube root of 10 lies between 2 and 3. Its approximate value is 2.154. This four-step strategy works for many problems. First, identify the type of root. Then, find nearby perfect squares or cubes, determine the interval, and finally, use an approximation if a more exact location is needed. Answer these 5 questions independently. Check your work by multiplying the answer by itself for square roots or 3 times for cube roots. Check whether the number inside the radical is a perfect square or perfect cube. If it is, the result is rational. If it is not, the result is irrational. Compare the number under the radical with nearby perfect squares or perfect cubes. This immediately tells us the interval where the irrational number belongs. Look at the numbers inside the radicals. 3 are perfect squares, but 10 is not. Therefore, the square root of 10 is the irrational number. The cube root of 27 is exactly 3, so it is rational. The cube root of 8 is exactly 2, which means it is not irrational. Since 3 squared is 9 and 4 squared is 16, the square root of 10 lies between 3 and 4. Its approximate value is 3.162, so B is correct. This mixed practice checks all the skills we learned. Take your time and identify whether each question asks for a root, classification, or location on the number line. For the last 2 questions, don't try to calculate the exact decimal first. Compare the number with nearby perfect squares or cubes. This is the quickest way to determine the interval. Here are the most important rules to remember. Perfect squares and perfect cubes give rational roots. Non-perfect squares and cubes give irrational roots. To locate a radical, compare it with nearby perfect squares or cubes. Congratulations! You have completed the Grade 7 Reviewer. Before finishing, check your answers and review any item you missed. Remember, identify perfect squares and cubes, distinguish rational from irrational roots, and use nearby perfect powers to locate irrational numbers on the number line. Excellent work, Grade 7 learners! Remember that mathematics becomes easier when we recognize patterns. Practice your perfect squares and cubes, and you will become faster at working with radicals and irrational numbers.